Hey everyone, so recently someone asked me if I could demonstrate how to make a character controller from games such as Ninja Temple, Slayaway Camp, Killer Puzzle. Killer Puzzle is basically an updated Slayaway Camp, but with Friday the 13th licensing. If you're not familiar with these games, it's pretty straightforward that you can choose what direction you move in. You just can't choose how long you travel in that direction. So, in other words, your character will keep moving until it intersects with an obstacle or a wall or something else that's in its way. So, if I press up, I keep moving up, so I cannot change direction mid-motion. I can only choose what direction, and then my character keeps stopping. This is actually an incredibly easy thing to do. There's just one little bit complex line of code, literally just one complex line of code that you should use just to make sure everything syncs up, because the actual control is easy, but very often the devil's in the details, and that what you have to do is you have to put in a little extra coding to make sure things don't go off the rails. Because pretty much since you're on a grid, you kind of are on a rail system. So and then say that basically maybe there was like a smiley face or something here that you have to pick up, and then that's why you have to navigate to there. Okay, so the key to this is that the obstacles should be a 1 by 1 size. So like this block in the middle here, it's just a 2D image that I imported. I drew it in MS Paint or whatever, and I just scaled it until it came to 1 by 1. Now, I don't know of any great way to guarantee a 1 by 1 size. If someone does, feel free to put it in the comments. I just eyeballed it. So I just took it until I could do this. You move it by 1, and you move it by 1, and the corners lined up nice and even. So that tells you it's essentially 1 by 1. If you're going to err, if you're going to make a mistake, do it on the side of being slightly too small, because that one line of code that I mentioned, it will adjust for you. So it doesn't have to be exactly 1 by 1. It could be, 0.99 by 0.95. It's not going to break the game. You just want to be really close. That's all. Because it won't break the game, but when the line of code runs and it readjusts the position, it's going to look awkward. So you do want to be as close as possible. So a 1 by 1 size, and since it's a 1 by 1 size, you also want to have it on. If you're going to have positions move, it's going to be again increments of 1 by 1. So in other words, I wouldn't want this to be at 1.5. Like that space does you no good. Your character can't travel through it, and now you're starting to make a mess for yourself. Okay, like the character would half intersect with this, so it kind of breaks the way the game's supposed to work. So you really don't want to do that. So you want 1 by 1. So if you're gonna place a block, you're essentially using a grid. Okay. Okay, so the block is modified so as that it fits a 1 by 1 position and a 1 by 1 size. And like I said, I just eyeballed it till I got it right. So that box is just a transform component, which is made by default when you drag and drop this into the scene. A sprite render, which is made by default when you drag and drop this into the scene. So the only thing I added to it was a box collider 2D. Remember, you have to use the 2D version because we're in a 2D environment. So you don't want physics, you want physics 2D. I dragged and dropped the elephant into the room, and then I also put a box around him. Again, wanted him to be close to 1 by 1, but it doesn't have to be exactly correct because, again, we have a line of code that is going to adjust for it. But you want it to be close because, like I said, if it stops and then readjusts too big of a position, then it's going to look janky. So you want it to be as clean as possible. Okay, now as far as the other objects, these are just the borders. So all I did was take this box and scaled it out. Now this doesn't have to be scaled out exactly as long as it's lined up. So this is on -9. So again, we're not using fractions. This one is on +9. Again, not using fractions. And since the rest of it goes off the side of the screen, in its case, it does not have to be an increment of 1 by 1, but that's only because it's going off the side of the screen. If you make any obstacles, you want them to adhere to that grid. So like if I click on this one, all I did was copy and paste it, and you can see that it is also position 1 by 4. I know I keep saying it, but that's key, is having that 1x1 grid. Okay, so basically all that's left is the coding. So what I did, is, and this is usually my default approach, I use the WASD keys just simply because people are used to using those for PC gaming, and like some keyboards like mine, for instance, that I'm using, WASD is actually red to let you know it's for gaming. You can use whatever control you want, but the input checking for those keys are pretty easy. So, took the elephant, and in his case, so again, he has the transform and the sprite renderer because he gets those when you drag and drop them into the scene. Added the box collider 2D. I showed you how to do that. I did set his box collider to be a trigger. I found that when it wasn't a trigger, it looked like there was an ever so slight bounce to it. And that's a problem. So I turned it into a trigger so there wouldn't be a bounce. Now, the trigger would mean it will pass through the object, which means we need a line of code on the on trigger enter that says stop what you're doing, stop moving. Okay. So yes, if it's not a trigger, then you don't really need the on trigger enter because it's not a trigger and it wouldn't do anything, but it bounces and then it might look a little weird. So we set a trigger there, and then the last thing is the rigid body, so it can actually be moved. The only thing I changed is gravity scale is 0. I believe it defaulted to 1, and then here's the hero script that get put on it. So we're already almost done. So like I said, so far this is really just straightforward, that the key is, again, knowing that you're on a grid and lining things up on that grid, both based on the size of the objects and the placement of the objects. Okay. So what does the script look like? Well, if we go to it, nothing in start. So unless there's something special you want to do, but in this demonstration it's not necessary. In the update section, you're going to see this. If you haven't seen it before, it might be a little bit intimidating, but it's rinse and repeat. It's really one idea repeated 4 times. It's saying if there's input, and that input is a key being pressed down, and that key is W, then do something. What are we going to do? Well, it's not a coincidence that it says get component. These are components. Get component. Which one? Rigid body 2D. Oh yeah, we added a rigid body 2D. And again, when you're typing this out, make sure you choose 2D. If you use just rigid body, it won't work. These two have to both be 2D. Dot velocity and new vector 2, 0, 8. You can have it move as fast or slow as you want it to. I notice that with these games, the movement tends to be kind of quick. I suspect it's because you don't have any control, so watching the character trudge along would be kind of torturous. So you can choose whatever speed you want, but generally these games tend to be kind of speedy. And now it's rinse and repeat. If input.get key down is S, so again, almost identical. Now we're just looking at the S key. Again, get component, rigid body 2D, velocity equals new vector 2, 0, -8. So the exact opposite. So they move the same speed vertically. So up or down. And again, rinse or repeat. If input.get key down, hopefully you see the pattern. It's just the same thing all over again. You wrote 2 lines of code and then you repurposed it. Input.get key down, A. And now we're going to move horizontally. So get component, rigid body 2D, velocity. And this time it's a -8. So it's on the x-axis. And of course, 0 on the y-axis. And then one more time, if input.get key down, D, get component, rigid body 2D, velocity equals new vector 2. And now it's +8. So you can pause the video, whatever, so you can copy this down. I used to type this out, but people told me it really dragged out the video and they couldn't stand the sound of me typing. So I try to type it ahead of time if I don't think it's going to be complicated. So if your eyes have traveled down a few lines, you're seeing that one line of code that's really ugly, but do not let it intimidate you, because as you can see, all the control is being done by 8, 9, 10, 11 lines of code if you can trigger, if you include that. So that's not much to have a character being controlled by so few lines of code. Okay, so as I said, if you're not using trigger, then the object will stop, but when the object stops, it kind of bounces and it doesn't look like it's in quite the right place. So 2 things. We're saying that when it enters a collider, so on, trigger, enter 2D, collider 2D. By the way, after you type this will automatically populate, and this will automatically populate. At least it should, okay? And again, make sure you're doing the 2D version. And then we're going to do two things. A, we're going to stop it from moving because, like I said, if they were solid objects, they would stop them. The elephant would stop when it collides. Okay. But since it's a trigger, we now need to manually stop it. So keep that in mind when you make certain decisions. There's going to be ramifications. In this case, using a trigger, I now have to manually stop it. Okay. So I say get component rigid body 2D dot velocity, and again, rinse and repeat, where it's the same principle. You're just repurposing it. And in this case, we don't want it to move anymore. We want it to be 0, 0. And last but not least, the line that I've prepared you for. This looks terrible, but if you keep in mind what get position does, so don't type this part. I just want to break this down for you a little bit, because I'd hate for you to get this far and then give up. So normally what you do, and again, we said that transform is a component, position is a part of the transform component, and normally what you do, you say new vector 2, and then you can do one of two things. You can either give exact numbers, so you give constants, say 1, 0, okay? Or you can give variables. And once you make a variable, you can make it as complex as you want. Like for instance, maybe I want to use the position that it landed at, but I want to increase it by 1. Maybe it's a teleporter, okay? So maybe you moved onto a teleporter, and the teleporter moves you one position over. So that is one thing that you can do. You can take the position that it's at and you can modify it. Well, that's what I basically did here, but I used a pre-existing function. So if you keep that in mind, this doesn't look so bad because, in other words, all this is x and all this is y. So it looks really messy, but that's what's going on. So what I did is exactly what I just said. I said, what is the current position that the object is in? And again, the object is the elephant. Okay, so what is its x position? Well, it might be 5.01, but we don't want that. We want it to be at 5.0 even. Okay, so what do? We're going to apply the mathf function, and then once you type in mathf, you can then say what you want. Well, in this case, we want round to integer. So mathf.round to integer and round this off, and that now sets them exactly at the closest number. Since you're rounding, okay, like I said, that's why you want to be really close to that 1.0. You want to be close so as that everything is roughly 1 by 1. If it's slightly less, it's okay because it's going to round down. It's not going to round up. So mathf round to integer transform.position.x, and then it's rinse and repeat. Mathf.round to integer transform.position.y. And that is the character controller. We'll run it one more time just so I can demonstrate that it's working. But that's a pretty simple character controller. Now, the only thing that this is missing is this is simply saying if W is pressed, if S is pressed, I'm not actually locking them out. So you would need to do something else. So while it's moving, you would need to lock them out. So you'd have to do something. Let me do something really quick. So like private string is moving. Don't think that's reserved. And it starts off with not moving. We'll say no. And then you just modify this to check to see if that variable is set to yes. And is moving. So is moving is equal to no. So if you're not moving, then go ahead and apply velocity. But that means is moving now needs to be set to y. And So you press W, is moving is set to N, so it starts to move. If you hit the button again, well, excuse me, you hit the button, N is set to, is moving is set to N, it starts moving, and it changes the value of is moving to Y. So if you press it again, this will no longer be true. This condition is not met, and so this will not happen. So it's that easy to lock them out, and then what you do is you reset this with the collision. So is moving is equal to no, because that's when they stop moving. So, and then it's just rinse and I probably won't type that out for the other ones. We'll know if it's working. I'll try to hit another. Actually, I am going to type that out. Sorry, because you could try. Whoops. I meant to copy, not paste. Because I was thinking I'd just press W again, but that doesn't really prove anything. We need to have all the keys locked out. And then we'll just run this, and then that should be it. If you want, I can add the smiley face as far as the object that you're trying to find, but that's simple collision detection. And now we just need to make this change as well. So again, rinse and repeat. I know I keep saying that, but I can't tell you how many times I've shown how to do something, and I can't help but think that at least some of the people, they're seeing the code only for exactly what I showed it. They're not really learning the code. They're saying, oh, this is how you do this one task, when in fact, no, this is the basis for a lot of tasks. So, all right, so if I didn't make any mistakes, that should do it. So first we'll just make sure movement still works. All right, now I'll try to interrupt. So we'll press A, then W, nothing. W, then D, nothing. S, then D, nothing. D, then W. Great. So there you go. There's your character controller. So to the folks who wanted to see Ninja Temple or those other games I mentioned, and I'm sure there's other ones that have used it, I just can't remember. That's how you do it. And like I said, you can always just take the smiley face, put him in there. Since he's an object that can be picked up, he doesn't necessarily have to conform to the exact one by one. His positioning should still be increments of 1, but his actual size doesn't have to be 1, because again, he is going to be a trigger, and he's not being used to stop. So physics, and you could do box collider, and then his trigger, and then he's called smile, and then you just do like a you're already doing on trigger enter, so you can just check to see if you're picking up the smile. So this you would not want to happen when you're picking up the smile, so you would have to say if it's not smile. So all right, so that's pretty straightforward. I mean, if you want to see me type that out, I will, but that's pretty simple collision detection, and the question really is just about controller and character movement. So there you go. I hope that you found this helpful. If you liked it, please leave a like and a comment. That way I know to keep making these, and please enjoy the rest of your day.